This is Calculus with Allenson, and we're going to do problem number 2 from the 2006 BC test. So there's a function L of t, and it tells you the rate that cars turn left at a certain intersection in cars per hour. A asks you to find, to the nearest whole number, the total number of cars turning left at the intersection from 0 to 18. So we're going to integrate from 0 to 18 the function L dt. So it's a calculator question, and we can plug L into our calculator and integrate, and we're going to get 1,658 cars. B says that traffic engineers are going to consider turn restrictions when the function L is going to be greater than 150 cars per hour. So find all values for t where L is greater than 150, and then compute the average value of L over this time interval. So what we want to do is we want to set L of t equal to 150 and see when that happens. And we'll use our graphing calculator to do that and find it happens when t equals 12.4283 and 16.1216. Okay, so we're going to have to let something equal these two values. So A equals 12.4283 and B equals 16.1216. So the reason that we do that is because we're going to need to find the average value between t equals 12.4283 and 16.1216. So we're going to 1 divided by b minus a times the integral from a to b of L of t dt, which is equal to 199.426. You do this part in your calculator. And this is in cars per hour. C says traffic engineers will install a signal if there is a 2-hour time interval during which the product of the total number of cars turning left and the total number of oncoming cars traveling straight through is greater than 200,000. And you know the oncoming one is 500, and so you would start off by doing 200,000 divided by 500, which gets you 400. So essentially we want to know if there's any interval where we get 400. So you kind of have to mess around, and you find out that from 13 to 15 is kind of nice numbers, and when you take that one from 13 to 15, you get 431.931. That's greater than 400, so that explains that since it's greater than 400, with 400, basically 400 times the 500 gets you the 200,000. Points for this one: 1 point for the setup here, 1 point for the answer. For B, there's 3 points, 1 for an interval when L of t is greater than 150, and it's between these two. I probably should have stated the interval as, maybe now that I've done this, from A to B for 1 point, and the average value integral, which is here, and then the answer with units. C is worth 4 points. Consider that there are 400 cars. Have a correct interval that's 2 apart that works. It doesn't have to be 13 and 15. There's some other ones that will work. And find the value of it and show that because it's greater than 400.